Thank you. So we got to start all over again.
Okay, sure.
So we're going to do the gravimetric analysis experiment, except in your module, I think I called it identification of the formula of a carbonate. But at the very end, I put gravimetric analysis bag. So this is it. And here you have some filter paper and 2 containers with compounds in it. So I'm going to open one of these up. And here we go. So this is compound number 8. And this is compound calcium chloride. Now, I'm going to describe how we used to do this experiment and why we've changed it. So the experiment used to be to identify a sulfate. So here are the possible sulfates that we used to have. You might have lithium sulfate as your unknown. You might have sodium sulfate as your unknown, or you might have potassium sulfate as your unknown. And to identify your sulfate, what you would do is you would react it with barium chloride, and you would make barium sulfate. Now, these are aqueous solutions. The barium sulfate is a precipitate. So if you can imagine here, what you do with your compound here is if you had lithium ions in there and sulfate ions in there, and you mixed it with a solution that has barium chloride in it, and you want to use excess barium chloride. So I'm going to put 2 bariums here, not 1, but 2, and 4 chlorides. So when you mix this, what would happen is barium sulfate would become a solid. Now here, if you take a look, only 1 barium would react. We'd have 1 left over. None of the chlorides would react. So I'm just going to put 4 chlorides. And your lithium would still be out here in the world, so to speak. Now you filter this through a funnel with filter paper. So here's your filter paper right here. And after you filter it, so here's the little drips of stuff coming through. What would remain behind would be your barium sulfate, because it's a solid and it doesn't make it through the filter paper. Okay, so what do you do with this barium sulfate? You take the grams of barium sulfate, turn that into moles of barium sulfate, and with that, you should be able to turn it into moles of whatever you have here. Moles of your sulfate. So sulfate means whichever one of these compounds. And because each of these compounds has the same stoichiometry, whatever this mole is, it would be the same if you had lithium sulfate, sodium sulfate, or potassium sulfate. So what do you do with this number? Well, you take the mass of your sulfate, divide it by the moles of your sulfate, and you get the molar mass of your sulfate. So once you experimentally find the molar mass of your sulfate, you compare it to the molar mass of each of these and say, oh, it matches that of sodium sulfate. So sodium sulfate is like let me think about this. Sodium sulfate is, what's 46 plus 96? 132? So sodium sulfate is like 132 grams per mole. Potassium sulfate is like 39 and 39 is 78. 78 and 96 is So, 79, 6, 185, something like that.
174.
174, did you say?
Yeah.
And lithiums are 9, so 18 plus 96 is like 116,
14.
114.
Yeah.
So when you come back with a smaller mass, if it's like 114, you got lithium sulfate. If it's 132, you got sodium sulfate. If it's 174, you got uh, potassium sulfate. Are you with me here?
Yeah.
Okay, so some of the issues you have to worry about is you have to make sure that every one of your sulfate ions precipitates. So you want this to be limiting and this to be excess, because you need to make sure every sulfate ion ends as part of barium sulfate so you can weigh it and get an accurate amount of your sulfate. Fair enough? Okay, so that means you use excess barium chloride. Another thing you have to do is when you pass this through your filter paper, the filter paper gets wet. The ions are so small that they're not trapped by the filter paper. They just stay with the liquid. But when the liquid wets your filter paper, some ions stay in that liquid. So if you have ions trapped in the filter paper because the filter paper is wet, how do you get those ions out of there? And the answer is you have to rinse the ions through the filter paper so that they go through. It's kind of like when you wash your clothes. After the wash cycle, your clothes still have that detergent in them, even though you spun the clothes. And so your washing machine goes through a rinse cycle where the soap in your clothes is diluted with, clean water. And then you agitate it to make it nice and even. And then you spin it and most of the soap goes away. Certainly a little bit of it stays because you can't get rid of all of it. And for people that are really sensitive, you go through a rinse twice. Some machines actually have that choice where you can say second rinse. Okay, so we need to rinse these ions out. And there is a clever way to do it. These ions should make it through the solution. And it turns out that if there's one of these ions there, they're all there. So there's a really nice little experiment you can do with the chloride ion to see if it's in your filtrate. This is called filtrate, the liquid that comes through. You add silver nitrate to it, because when you add silver nitrate to it, if there's any chloride, it'll turn cloudy right away. So what you do is you check after you filter this, there's ions in there, so you dump this stuff. Then you rinse it. And if there's any ions in the rinse, it'll react. If that reacts, you dump it. And then you rinse it again. And if there's any ions in the rinse, it'll react with the silver nitrate and you dump it. And you keep rinsing until you don't get any cloudiness. Okay, so this is what we used to do. Now, here are some of the problems with this. Well, actually, here's the pros. These are the pros of doing it this way. Most sulfates are soluble, and barium sulfate is not. So what's nice about that is if we're trying to precipitate the sulfate, it's very unlikely to precipitate with anything else. Therefore, we should get pure barium sulfate. So that's the big pro of this experiment. Now the cons. The cons are as follows. Dissolved barium ion is a toxic heavy metal. So if you have barium ions in your rinse, you have to collect that rinse and you cannot pour it down the sink. So when we do this in the lab, we collect it in a large container. None of it goes down the sink. The other cons are that, let's see. Well, that's the big con. That's it. All right. So if we're going to be doing this at home and we don't want to work with the toxic heavy metal, we've got to adjust the experiment. So here's the adjustment that was made for your experiment. You will either have lithium carbonate, sodium carbonate, or potassium carbonate. And there is a key that has the number of your unknown, on it, and it says what it is. I don't have the key, so I can't tell you what your unknown is. I don't even know what mine is. We're going to react this with calcium chloride, and we're going to make calcium carbonate. And we're going to have the leftover, which would be lithium chloride in this case. You can see I'm not writing out the formulas because I want you to figure out what the formulas are for everything. So you get your reaction all nice and balanced. And in this case, we want this to be limiting. And we want this to be in excess. And this is going to be a solid. And this is going to be aqueous. So in our case, when we do the filtering, inside of our filter paper, we're going to collect our calcium carbonate. And we're going to do the same thing. We're going to figure out the moles of calcium carbonate or the grams of calcium carbonate, turn that into moles of calcium carbonate, turn that into moles of your carbonate. And because you measure this, you'll be able to figure out its molar mass. So the pros of this experiment are that everything's non-toxic. But there are some cons to this experiment. For instance, our carbonates, these carbonates right here are hygroscopic. Now, hygroscopic means that they absorb moisture from the air. So when we go to weigh our carbonate, if it's absorbed moisture, we're not getting a correct mass. And we got to get rid of that moisture. Another con with this experiment is that carbonates are not soluble. So that means anything would precipitate with the carbonate. So we got to make sure that we don't accidentally put anything else in our solution. Another con with this one is that carbonates and acid turn into H2O and CO2. And the CO2 would bubble out, and that's a problem. So you want to make sure that you don't put any acid in your solutions either. So there's a number of cons with this way of doing it, but the non-toxic pro overweighs all the cons since we're doing this in our kitchen. Fair enough? We don't want to harm anyone in the experiment. Okay. So what is the procedure for doing this? Well, the first thing you want to do, I would say, is you want to dry your carbonate. So here, this is my carbonate, and I actually dried this sample earlier today. And the way you dry it is you put it into a beaker and in the oven at 200 degrees Fahrenheit for 1 hour. Now, naturally, you're not going to put this in the oven because it's got tape on it and it's got plastic on the cover. And besides, if you want the moisture to leave this thing, you want this thing to be open. So I would suggest using one of your beakers that you have. You know, one of these guys. These guys can be heated without cracking. So just dump your carbonate in there and put it in the oven for an hour. And then after an hour, let it cool down to room temp before you use it. So are you good on that very first step?
Yep. you got
Excellent.
it.
Second thing you want to do is you want to weigh the filter paper. Now, the reason you have two filter papers is in case you mess up. Now, you might expect the filter papers to weigh the same amount, and they may weigh very close to the same amount, but probably not precisely the same amount. You want to make sure your filter paper is dry. If it does get wet, you can put your filter paper in the oven at 200 degrees for a few minutes and it will dry. Paper ignites between 400 and 500 degrees Fahrenheit. So at 200 degrees, it shouldn't ignite. Okay, so you can see that I took my filter paper and folded over in two, and I'm going to fold it over in two again. And I'm going to put it on my balance and weigh it. And to keep track of this, you normally want to put this in your lab notebook. But I also like to write the number on my filter paper in pencil, because the pencil won't run when it gets wet, but pen would. So that's one filter paper. And I'm curious to see how close the filter papers weigh in mass. I think they're going to be pretty close, but the one was 1.28. This one may be a little different. And it is, it's 1.27. So I went ahead and wrote that on the filter paper. So there's your filter paper. It's been weighed, and I'm going to put that off to the side. Now you want to weigh your oops, I turned that off. Turn that on. You want to weigh your unknown. Since this one I dried out, I'm going to use it. And you want to use usually between 0.5 and 0.7 grams, somewhere around there. And so you can see I've tared my balance, and I'm going to put this into my flask. And here I got 0.68 grams. That should be fine. And of course, you want to record that number. So what's the third instruction here after you say weigh your filter paper? Weigh the carbonate. Now, when I say carbonate, that doesn't mean carbonate ion alone. It means either lithium carbonate, sodium carbonate, or potassium carbonate, whichever one you have. You'll be trying to figure that out. So here I have this weighed, and what I would like to do now is I'd like to dissolve it. But I'd like to dissolve it in the minimum amount of water that it takes to dissolve it. Now, remember, I want to turn every carbonate ion in here into calcium carbonate. And this is going to react a whole lot better if it's dissolved than if it's not dissolved. But since I'm going to filter it, I want to have as little water as possible so that I'm not filtering a whole bunch of water. So the reason I remove my paper is so that you can see whether or not the solution is clear or cloudy. And it's getting pretty clear there. I'm just going to add a little more water. Now, you might be wondering, well, why am I not stirring this with my stir rod? And the answer is, if I stir it with my stir rod and I pull it out and there's a drop of solution on it, that drop will have carbonate ion in it, and I'm taking it away from the solution. So I'm not going to stir this with my stir rod. If I did stir it with my stir rod, I'd pull my stir rod out and I'd swish it down with a little bit of water to rinse all of the solution back in. Okay, so there's my carbonate dissolved. Now what you want to do is you want to figure out how much calcium chloride you're going to need so that you have excess. And for this one, just pretend you have lithium carbonate and you just measured the mass. Figure out how many grams of calcium chloride you're going to need to react with that and double it. Okay? So what I'm going to do with that now is I'm going to pretend I've made the calculation. And so here's my balance. I'm going to turn this on. And you'll notice I have placed the balance so you can't see the mass. Tricky, aren't I? So here's my calcium chloride. And again, you want to make sure that you use well enough to be able to react with all of your carbonate. And now that I have my calcium chloride, I'm going to dissolve it. Now this stuff doesn't dissolve as well as your carbonate. And I'll show you what I mean here in just a moment. So again, I'm trying to use the minimum amount of water to dissolve this. And for this one, I really don't mind if I use a stir rod, because if I lose any of this, it won't matter because it's in excess, as long as I don't lose too much. Okay, you can see it's dissolving pretty well. And the problem with this stuff is that it does end up staying just a little bit cloudy when everything's dissolved. But this one, you can actually see chunks, which means it's not dissolved. So I'm going to add a little more water. I'm going to swirl it. And while I'm swirling it, I'm going to say that for this experiment, you know, it's just going to take a little bit of patience to be able to get it right. So while that's dissolving, what I'm going to do is I'm going to bring back my directions here. And I'm going to say, okay, well, you weigh your carbonate and dissolve in water. 4, weigh excess calcium chloride and dissolve in water. And here, for finding out how much excess you need, here pretend you have lithium carbonate. Calculate the mass of calcium carbonate needed to react, and then use twice as much. And that X means times. Use 2 times as much. Okay, so that's how you figure out how much of this stuff to use. All right. So now I have my 2 solutions, and this one is still a little cloudy. And I'm going to add a little more water to see if it helps. And you're going to find that it doesn't help a whole lot. So this is my calcium chloride solution that I'm swirling in my hand. You can see that it is pretty clear. You know, it's a little cloudy. And here's my solution of my carbonate. So what you want to do is you want to add this to your carbonate. And with this, you can see that I'm starting to get this solid forming in here. And that's my solid that I want to collect. It almost looks like a gel. Okay, so how do we filter this stuff? Well, do you remember that filter paper I told you about where you fold it over twice? This is what you're going to use. And you're going to use a funnel. And you're going to use a Erlenmeyer flask. So the funnel goes in the Erlenmeyer flask like so. And your filter paper, if you open it up like this and put it in, that's not how you want to use it. But you want to open one of these folds up like that, and you end up having a little cone. So the cone goes into your funnel like so. So that's your filter paper for collecting material. And you can wet your filter paper down just a little bit with some water. And when you wet it down, it'll end up sticking to the funnel and staying open like that. And then you want to take your solid and you want to pour it in there. Now, when you pour this in here, you want to make sure that it doesn't go over the edges of the filter paper, because solid will go over the edges and you'll lose some. Also, you can see I've got leftover solid in here. So what I'm going to do is I'm going to use my water bottle to rinse that solid back down to the bottom. And then I'm going to swirl, and you can really see how cloudy that's getting. I'm going to swirl, and I can put that in there too. I still have a little bit of solid left in there, so I'm going to do this again. And I'm going to do this as many times as I need to get this to work. And the whole time when I'm passing this into the bottom, into my filter paper, I'm making sure I do not breach the edges. Now, I can't show you the bottom of my, well, I guess I can. I'm going to do a different share here. Actually, I'm going to stop share. So here you can see what this looks like from the side. And do you see that little drip of water coming out? So that drip has lithium ions in it, or sodium or potassium, depending on what it started with. And it has chloride ions in it, and it has excess calcium ions in it. It should have no carbonate ions in it. Now, if you see how slowly that's dripping, that's like one drip every 2 or 3 seconds, or maybe a drip every 2 seconds. So one drop, well, there's about 20 drops of water in a milliliter. And so that means if this is doing one drop every 2 seconds, that's like 1 milliliter every minute, or a little less than a minute. But let's just say 1 milliliter per minute. So if I'm filtering 10 milliliters, it's going to take me 10 minutes. 20 milliliters, 20 minutes. 30 milliliters, 30 minutes. So this is why I'm trying to minimize the amount of water that you use, so that you don't have to filter for such a long time. Okay. So when you're done filtering, some of those ions will be stuck in the wet filter paper. And what do you do then? Well, what I have here somewhere is, well, I have another filter paper here, and I'm going to do a different share now. So what do you do when this has filtered all the way through? You want to rinse your filter paper with water. And you basically want to start at the top edge and work down all around the edge. Start at the top edge and squirt the edges so that all of the liquid rinses down the filter paper. And as it rinses down the filter paper, it'll be bringing the ions with it to the bottom of the filter paper and eventually out of the bottom of the filter paper. Now, the ions I'm talking about, of course, are the ones that are not part of the solid. And you want to rinse this about 3 times. And if you're rinsing with, like 2 or 3 milliliters at a time, each rinse is going to take you anywhere from, 3 to 5 minutes, depending on how much you use. So let me put this off to the side now, and let's catch up on our directions. So you weigh the excess calcium carbonate and dissolve in water, and you add the calcium chloride. I said calcium carbonate, I meant calcium chloride. Add the calcium chloride solution to the carbonate solution. And a precipitate should form. And I was really quick about beginning to filter. You don't really want to do that. Once you dissolve these in water and mix them, you want to let them mix for a while. So mix for, let's say 5 minutes. And then what you want to do is you want to fold the filter paper. Twice. Put it into a funnel. Wet it. And then filter the solution through it. So here is your funnel. This is your filter paper. And you're going to filter your funnel through it. And the funnel is going to be put in your Erlenmeyer flask like this. This is supposed to be a drop coming out of the bottom. And then after it's done filtering, you're going to rinse at least twice. And by rinsing at least twice, I mean you rinse it and let all of the liquid filter out, and then rinse it again and let all of the liquid filter out. And this makes me think I didn't wait quite long enough to filter, but you see how the solution here is a little cloudy, but it's not too cloudy, so it's probably okay. Okay, so what do you do after you've rinsed twice? Well, you want to dry the filter paper and the product together. You don't want to try to remove the product from the filter paper. So what you do when you dry these is you dry it in the oven at 200 degrees Fahrenheit for about an hour. And it should dry completely. But how do you make sure that it really has dried completely? And the answer is repeat. So dry the filter paper and product in the oven at 200 degrees Fahrenheit for an hour, cool, and weigh it. And then repeat. Because when you're done, if the mass is the same after you cool it and weigh it, that means all of the water has left. If the mass goes down, that means more water is leaving and it wasn't really dry. So, Greg, do you have any questions so far about these directions?
Nope, pretty thorough.
Okay, and when you're done with the solutions and when you're done with the filter paper with the solid, the solutions you pour down the sink, they're non-toxic. And the solid that you made is calcium carbonate, which maybe some oyster might appreciate so they can make it part of their shell, but it's harmless. You could even throw that out in your garden and put calcium in the ground. I don't think it would really help that much. There's not much there. I just throw it away. Okay. So the idea is you're going to take your carbonate. So remember, this carbonate is lithium carbonate, sodium carbonate, or potassium, one of those three. You're reacting it with calcium chloride. You're making calcium carbonate. And you're making a chloride over here, either lithium chloride, potassium chloride, or sodium chloride. This is going to be a solid. This is going to be aqueous. This is aqueous, and this is aqueous. So this is what you're going to collect. And once you collect it and you get the mass, and the way you're going to get the mass is because you weighed your filter paper first. And then after you dry your filter paper with the product and cool it, you'll subtract the mass of the filter paper alone from that to get the mass of your product. Does that make sense there for getting the mass of your calcium carbonate?
Yep.
You're not going to scrape it off the filter paper. We don't mess with that. You're just going to weigh the whole thing and subtract. We call that mass by difference. So you can take the mass of this, get the moles of this, and then get the moles of your carbonate. And your moles of your carbonate, and remember, you've weighed this, so you already have the mass of your carbonate. I'm going to call it moles, mass of carbon, moles of carb, because you know how it is. No one eats carbs anymore, so we're going to have carbs in this lab. Did you like that? Was that one a groaner?
Yeah, that was pretty bad.
Okay, so you're going to take the mass of your carbonate, divide it by the moles of your carbonate, and that gives you the molar mass of your carbonate. And if you write out the formulas correctly, you should be able to get the molar mass of each of those and make a match. How's that sound?
Very cool.
Now, I want to give you a couple of caveats on this lab. One is that there is going to be a lab write-up, and you're going to write up introduction all the way through discussion. For the discussion, you won't be able to say with any certainty that you're correct. But hopefully, if the molar mass comes really close to what you expect, you're going to say with not absolute certainty, but with you bet your bippy certainty that you think you're right. Okay.
And how do you spell Bippy?
I think it's B-I-B-Y, isn't it? Bippy?
I just making sure I got my scientific terms right.
That's not a scientific term. That's a laughing term. Are you old enough for that TV show?
Unfortunately, yes.
Then you know where it came from. And I think it was actually, you bet your sweet Bibby. I leave the sweet out.
Gotcha.
Okay. So you will be able to comment on your confidence that you got the correct answer. So the other caveat is you're actually going to write a lab report on this particular lab. It won't be due until after spring break. But I will be writing a lab report based on the formula of a compound from combining masses, the one with the magnesium oxide. I'll be writing a lab report based on that as an example of what I expect for you guys to write. Does that make sense?
Sure.
And I'll produce that for you at the beginning of spring break, so you have all spring break to look over that and start working on your lab report. Also, I'll be telling you, because in your lab write-up, you want to say, well, I think whatever your number is, 26 was sodium sulfate. I'll be able to tell you if you're right or wrong. So in your lab report, you'll actually be able to say with certainty whether you were right or wrong. And regardless of whether you're right or wrong, you would talk about, what are the issues with why the numbers weren't precise as you wanted them to be, or were they as precise as they could be, and so forth and so on. Okay?
You got it.
And that's it. This is supposed to be a kind of easy lab to do. A lot of people worry about when they filter that the filtrate comes out a touch cloudy. And what I tell people about that is, well, if it's a touch cloudy, what you can always do is you can take a beaker, weigh it without anything in it, put that stuff in the beaker and dry it completely, and weigh the beaker afterwards to find out whether that cloudy material has substantial mass. I can't tell you the number of times where a student has their filter and there's solid in there, and then there's a couple of pieces of fine hair in there, like you might get from dust. And they ask me, how will this affect my result? I mean, is this going to be a problem? And my answer is always this: well, if you want to find out, take a piece of dust and put it on the balance and see if you can weigh it. If you can't weigh it, it's not a problem. Does that make any sense?
Yep.
So that's, that's the way you always, deal with, well, is it going to be a problem? Well, you find out if it is. Now, I'm not saying throw dust in your material. I'm saying throw dust on the balance to see how much it weighs. And I think you'll find out that even though you have some cloudy material, it's not going to be a big deal. But the thing you do need to worry about is if when you filter, it's really cloudy and you can't see through the solution at all, you lost a lot of solid. And there I would be concerned. Capiche?
Gotcha.
Okay. Do you have any questions you want to ask about this?
Nope.
Okay, well, it looks like we're going to have an early night. Thank you for calling in. I hope you found this useful. I'm going to put those directions up there again one last time so that if anyone's looking at this, they can kind of freeze it and look at it. But you want to dry your carbonate at 200 degrees for 1 hour. And I should say, cool it. Weigh your filter paper, weigh the carbonate after it's cooled, dissolve in water, use the minimum amount of water you need. Pretend you have lithium carbonate and calculate the mass of calcium chloride you would need to react with it, but use 2 times as much because you want this in excess. Add the calcium chloride solution to the carbonate solution, and a precipitate should form, and mix for 5 minutes or let it sit for 5 minutes so that the precipitate forms fully. Fold your filter paper twice, put it into the funnel, wet it, and filter the solution through it. Now, that filter paper, when you fold it twice, this is what it's going to kind of look like from the top. And so that's the filter paper going down. What you really want to do is you want to get in between here for the filtering. So there's going to be like 3 layers on one side and 1 layer on the other side. And that's where you filter your material. Okay, you want to make sure that you don't leave a way for your material to leave. Now there's another way. I'm going to show you very quickly. There's another way to use your filter paper. And that's this way. You fold it in 2, and then you make like a little fan out of it. So you fold it. I don't know if you can see what I'm doing there, but it's almost looking like a little fan. In Japan, we always used to buy these fans that were shaped kind of like this. And when you open them up like that, it's a fan, and you could, fan yourself. And, we used to do this all the time. And you can put this into your funnel instead. And this works just as well. The pros of doing this is that you have more surface area, so it filters faster. The con is there's less volume it can hold because of all the ridges that fold in. So you can only put a little bit of liquid in here at a time compared to the other method. But they both work equally well. And the other caution here is when you dry your filter paper and product in your oven, when you remove that from the oven, you want to make sure you don't spill your product, because if you do, you got to start all over again. So just be real careful, use oven mitts or let it cool in the oven and then take it out when it's cool enough when you can handle it by hand. So I think that's enough of to work with, and I'm going to let you go. You have a good evening there, Greg.
You bet. Thank you very much, Tony. Appreciate the class tonight.
What's that?
Appreciate the class. Thank you.
Okay, you're welcome. Bye-bye.